Can you hear me?
Yeah, we can hear you. Okay, great. Hello, everyone. Thank you for a bit of patience there, just getting everything set up. Tech-wise, it's always a nightmare trying to have presentation in the room and online and make sure the audio and video is all working in both places without getting horrible echo. So yeah, thank you all for coming. Thank you for braving the heat. I know there were some people who couldn't make it because trains got cancelled or whatever. But it's great to see so many people who did come, and yeah, you'll be pleased to know it's air conditioned here. It's nice and cool, and the drinks are cold too. So yeah, thanks to Alex, our first speaker. He's going to talk to us about autonomous vehicles and how they do massive scale inference. Before we get started, I just wanted to say a kind of big shout out to my company Selden, who not only give me the time to work on this, but they also sponsor this by paying for the food and drink and stuff like that. If you haven't heard of Selden before, we're an MLOps company. We provide tooling to do model deployment, management, explainability, and monitoring. So if any of those things sound like something you want to do, we have open source stuff as well as an enterprise platform. Hit me up, or there are a couple of my colleagues kicking around. Maybe they've all disappeared now, but I don't know. But yeah, anyway, whatever. Yeah, come find me and we can chat about it at some point. So yeah, I think that's it. The way we'll do this, Alex will speak, we'll have a short break, you can go and grab another drink or some food, and then Byron's going to speak next. And that will be a bit more of an open discussion. So for this one, if you could let Alex speak, and then we'll do questions afterwards, I'll leave plenty of time for that. So yeah, take it away. Thank you very much.
Okay, thanks, Ed. And thanks, Julio, my one colleague who's made it today to come and watch. So yeah, I'm from Wayve, and the idea behind this talk is I thought I'd talk about one of the projects that I've been working on over the past 6 months, which is quite, here's another Wayve colleague who's just walked in. Yeah, one of the projects that I've been working on recently, which I thought was quite cool and interesting to talk about, and the idea is that hopefully I can explain it in enough detail that maybe we can discuss what I could have done better, where we can go further, maybe what was good about it. So yeah, that's the idea. So to start off, I'll explain what we do at Wayve as a company and where this project fits into the wider context. So also shout out to our public relations team who made all of the really fancy slides, which I'm now just copying. So yeah, we are a driverless car company, and we started in 2017 in Cambridge. And basically our main thesis is that we want to use pure end-to-end deep learning to drive the cars with images as input and direct control of the vehicle as an output, rather than a very complex and hand-coded software stack. Yeah, and so basically the idea is that, yes, driverless cars are very good for the world. And yeah, so basically the whole idea behind end-to-end deep learning that we're using, this AV 2.0 idea, is that there's no way that you can build a hard-coded set of rules that would describe everything from snow to reindeers jumping in front of the car to the busy streets of mopeds and stuff in Cairo. That's just completely impossible. And in fact, all of the existing people in this area have really struggled to actually go from a proof of concept to something that can actually drive on public roads, to the point where we don't think it would be possible at all. So what we're doing is getting rid of all of the hand-coded HT maps and all of the LiDAR and expensive sensors and stuff, and just letting AI do its thing and praying to the gods of deep learning is basically the idea. So yeah, and we've got a fancy quote from Jan de Kun there. He's an investor. So yeah. So this is the idea. This is kind of a classical AV 1.0 stack, and you have all of these different complex modules, like a lane detection module and a traffic lights module, and roundabouts and stuff. And then you combine all of these custom enrichments of the perception data. And then you have like maybe a classical planning module, which can learn to drive, like can just drive without learning according to a set of rules. Whereas we are using big end-to-end neural network, very deep, very complex. The idea is that it will actually learn like a human with a perception module and a control module, all as part of the same network. And yeah, here's some cool videos of us driving in complex situations. Very nice, very fancy. So yeah, the project that I've been working on is auto-labeling. So as I mentioned before, we have these big control models that we train, which are the things which are actually driving the car. But then the job of the company really is to research and develop these models, and there's a lot of kind of support work that goes into that. In particular, one of the things we've been looking at is joint training these models using labeled images as part of the training samples. So this is what these images will look like. This is like a segmentation map. So here, basically, we've identified for each pixel what that pixel is, and then we've made a mask of the original image that's labeling that, and then a similar thing where for each pixel in the image, we've got the depth, the estimated depth of that thing in the image. So like, obviously, like the road is nearby, the tree's kind of nearby, and then you've got the horizon. And then what we'll do is we'll use these what we call teacher labels as part of the label for training our neural network. Now, you can get companies to make these by hand, so using some kind of computer-assisted tools. They'll literally label what's in the scene, and maybe you can get a few thousand, maybe like 100,000 if you pay a lot of money for those. But we have data sets of billions of images, and if we're training the model, we need labels for all of those images. So it's not possible to have some company like label these things for us. So the idea is that we get a state-of-the-art perception model which can produce these estimates for us, and then we run that in the cloud at scale to label all of the images that we're going to use for training, and then we can use that to train our control model. So yeah, basically the setup of this is that if we have a researcher that wants to train a model with maybe like a new kind of label or a new perception model, they should be able to draw up a config file describing what they're going to do, what data set they want to label, what model they're going to use. And then we send that off to the cloud, and that's going to then run at scale, and in as short a time as possible, it's going to produce billions of these labels. Now, one of the problems is that our data sets that we will send, that we'll use for training are not actually data sets of images, they're just references to images, because we can't, with the scale that we're operating at, we can't copy our images, and we can't like allow some researcher to then make a data set which contains a copy of a big chunk of our data, because it'd be super expensive. But yeah, these data sets are Parquet files, they're references to images. And when we do this labeling process, we need to make sure that we're not wasting time and money by reprocessing images that, say, someone else has requested. So yeah, we need to process this in like a batch style and then deduplicate, so we're not reprocessing. So then this is kind of different to like typical production model serving, because where you might normally in a model server, you'd have like a model in production and everyone can hit it, and it will typically serve like low latency online requests. Whereas we want a completely arbitrary model that's been uploaded to then be processed in batch at scale. And then obviously all the kind of normal things around batch processing, like robustness and like, yeah, robustness and cost efficiency. So before this project, we were actually using our DGX training machines. So I don't know if you have used these before, but they're like $200,000 each. and pretty expensive, and actually only have 8 massive GPUs on them. So although they're super cool and great for training, they would still take months to process just one data set. And over that course of months, hiring it from Azure would cost tens of thousands of dollars. And that's for each time that we run this batch job. So we wanted to get away from doing it like that. And then, yeah, so then basically with the project, we started looking at different ways we could approach this. And one way was, so we have a Kafka already running in production. And so we thought maybe we can set up like a normal inference server using something like Selden Core or like NVIDIA's Triton inference server. And then we have like a CLI tool or something that would then submit a load of jobs to a big Kafka queue. And then the server can consume from the queue and put the images somewhere. So this was the first thing we were running with. And well, it seemed good, but then we had a lot of problem in the design with how we can then deal with the batch like component of that. So if you have multiple people submitting samples, then how do you do deduplication and stuff? So, oh, and then also then we're implementing a lot of stuff here ourselves because we're kind of building it on top of kind of lower level components. So this was one of the approaches that we looked at, and maybe, I don't know, if you think this would have been a good idea and we should have gone with that, then let me know afterwards. But then the next thing we actually did was using Databricks. So Databricks is like managed Spark, if you're not familiar. And Spark is much better suited for batch processing. So we can write some high-level code in PySpark in Python, which then takes in all of these Parquet data frames, deduplicates them, compares them against like what's already existing in the cloud, works out which new samples need to be labeled, and then would run like a Python UDF, so it would just call a Python function repeatedly to then call the model with PyTorch and get the inference result and then upload it. So yeah, this is what we went with initially. And it's good. The PySpark part of it was working well. And we already had a lot of the infrastructure set up because we do have a big Databricks footprint already. But one of the big problems we found is that, so we set that up, we're using spot nodes. So rather than using these, I'm gonna take a step back. So rather than just using one DGX server, we then have PySpark running on a whole cluster of servers. So there'd be much cheaper commodity GPUs, like we're using a T4. And we can also run those in spot mode. So we're paying 1/8 of the cost of the on-demand cloud nodes. And so we can absolutely slash the cost compared to running it with like single large machines. The problem then with Databricks is once we've slashed the compute cost by using these really efficient, cheap GPUs, actually the Databricks surcharge that they charge for using these clusters then dominates the cost of this cluster. It's like 80% of the cost is not in compute, it's in Databricks surcharge. So that was not a great use of funds in our view. And then also like the fact that Databricks is not really open source, we had a lot of trouble setting us up in the first place. So I can go back to this slide. So yeah, so actually I think when we were speaking to them, we were the first people to ever run custom Docker images with GPUs on their platform, which was cool for us, but also not great because we don't want to be the pioneers of doing things on their platform. We want a managed platform where it's all done for us. So that was worrying. And then we were also the first people to do, to request like extra shared memory, which you need if you're running multiple PyTorch data loaders. So we had to like then get a lot of stuff changed, and we had to request them to set up T4 nodes because they only had some other type of GPU. So actually a managed service was not really what we wanted because the scale that we were running at and the level of customization that we wanted for our PySpark platform was too much for this service. So although it was great for what we're doing with notebooks and stuff, it was not really a good fit here. So what instead we did is then instead of running our PySpark jobs on Databricks, we ran them directly on our Kubernetes cluster. So we're all in Azure at Wayve, and we have an AKS cluster, which is basically our production cluster, where we run all of our jobs. And it's all nicely set up. We've got everything how we like it. And then there's this great Spark operator, which you should check out if you're doing this kind of thing, which allows you to run Spark jobs directly on the AKS, on the Kubernetes platform as like a custom operator. And it gives you full control over everything you're doing. It's all open source. You can SSH to everything. It's much better for our use case. And then there's no surcharge. So AKS doesn't charge an extra fee on top of the underlying VMs, and there's no Databricks here. So this is great for us. We're literally paying for the pure T4 cheap spot GPUs, which really cut down the costs when we were running this at scale. So this is what we eventually have stuck with, is PySpark on AKS to run our inference. So just to go a bit more detail into that then, we have this PySpark job, which will read in a Parquet file of references to images. It will compare it to what we have already labeled in the cloud and deduplicate, so that we have like then a data set of images to be labeled. And then it will call a Python UDF for each sample, which then has a PyTorch model running. So like a scripted PyTorch model, which will then run, it will produce these output teacher labels, and then we will upload them asynchronously back to object storage. So that's how it works. And then this now we've scaled up to 900 GPUs, which is actually limited by the size of one cluster in AKS. You can't have more than 1,000 nodes in one cluster, and we need 100 for the whole rest of the company, really. So it's quite dominant in terms of what we're putting through Kubernetes here. And this has reduced the cost of these jobs by 20x, which is pretty huge, I think. And yeah, our head of engineering was quite happy with that. And yeah, it's 100 times faster at least. So now we can label something like 1 billion images in 24 hours, which is quite a lot. Okay, it's not 1 billion images. It's whatever that number is, 480 million. Oh no, it is 1 billion, because it's 480 million camera inputs, and then we're producing segmentation and depth labels for each of those. So yeah. And now we have about 10 billion of these labels in Azure, which is quite a lot, especially when you try and list a directory by accident. It doesn't work. So yeah, this is to give you an idea of the scale of this thing. Just the power draw reported to Datadog for the GPUs is 90 kilowatts. So that's excluding the rest of the server, the networking stack, the cooling, everything else. And that's 120 horsepower, which is quite mad when you think about it, when you run a CLI command and it just trundles off and it's literally doing that. And at this point, I should point out that Azure does actually offset all of their energy usage. So we're hopefully not destroying the planet too much when we're doing this. And yeah, as you can see, at the quoted energy efficiency of the iPace, you could literally drive to wherever that is, Afghanistan, with just one labeling job. So yeah, this is quite a large scale thing that we've now set up just using PySpark and AKS. So yeah, here you go. So this is now processing 1.4 gigabytes a second of images through a state-of-the-art perception model with like a ridiculous number of parameters, and then uploading them back again. at 300,000 images a minute. And you can see it maxes out the GPUs as well. So it's pretty efficient. And then you combine this GPU efficiency with the fact that it's on spot commodity hardware, which is like 12 cents an hour, gives us quite good like ROI for this task now. So yeah, that's the good side of this project. And then we've now been running this in production for about 6 months, and we've got a lot of value from the labels. One of the problems that we've found is that it's quite hard to integration, like to test this stuff properly, especially as all of the the inference logic that we have. So the thing that's running inside the Python UDF is built on top of our AI monorepo, which changes very fast with ongoing research, and our integration tests aren't really thorough enough to keep up with all those changes. And then another issue that we've found with this project is that now it's not in Databricks. It doesn't have a nice UI. It is just directly running on our Kubernetes cluster. We have some stuff. So we have tailing the Kubernetes logs and grepping them and displaying the Spark UI through a temporary Kubernetes ingress to provide a sort of a decent level of user friendliness. It's still more challenging than something that's say running locally on a local machine or running through Databricks. And then of course, I don't know if you guys have used Spark a lot, but the error reporting is really bad. And when you get a stack trace, it's thousands and thousands of lines of Java stack trace, and then you scroll up and it's a meaningless error. So that's actually quite challenging for users as well. So then we started thinking about where we're going to take this in the future and how we can improve on that. And what I'd like to do is go back to using an inference server. So we've been looking at Selden and NVIDIA's Triton inference server. And the idea is that we'd still use a Spark cluster, and it would just be a CPU Spark cluster. And then the Python UDF, instead of actually containing a model and actually running inference, it would make a gRPC call to our server, which would then return the result back. So all of the business logic of deduplication and managing the Spark tables will be done on a CPU-only Spark cluster, which can then go back to Databricks with all its nice user friendliness. And then we have one centralized, massive GPU cluster, which is going to take in all the requests from all of the batch jobs and anything else that we throw at it. And then we can centrally manage this big ML inference server. So that's one area that, I don't know, maybe if anyone in the audience has experience with or comments on whether that's going to be a good approach or a nightmare waiting to happen. And then the other thing is maybe we do actually want to go back to some sort of Kafka-based architecture where we can send off requests and then stream them in. Although, to be honest, I'm not sure how we would make that work. Or maybe anyone in the audience has a completely different architecture for running inference like this at scale, in which case, please definitely speak to us and let us know about it. So thanks for listening. That's the talk.
Brilliant. Thank you very much, Alex. Just if everyone in the room can hang fire for a second, we've got some questions on the chat online, so I'll do those first quickly, and then we'll jump into the room. Firstly, just wanted to mention you've got some love from people on there about the Spark error handling. People saying it's dreadful but necessary evil. Okay, so is Wayve's approach single or multitask? If multitask, what tasks do they divide the problem of self-driving into?
It is single task. Yep. At a high level, the architecture is that we have a perception module, so set of layers, and then we have a control module, and then we have a loss function which might have different aspects of the loss, which can then kind of describe the reward of different types of behavior. But yeah, single task.
Okay, cool. And then, what's Wayve's view on how an end-to-end neural network-based model for driving can be understood and trusted?
Good question. How do you trust a black box which you feed data into and then pray to? We have a whole team that's dedicated to that called abstraction and reasoning. One of the approaches, actually, something that I very closely related to this. So we're using ensembles of models. So we'll train a model several times with slight variations, and then we can see how the outputs differ by these supposedly same models. And if it's very uncertain, then they'll produce like a wide array of outputs, and then we can plot that on a heat map, so we can see that when it gets to a junction, it's pretty uncertain about what to do, or like in multi-lane scenarios. So that's one way we can look into understanding the model is, its variation. Apart from that, not really sure.
Cool. Yeah, we just got to get the benchmarks so good that everyone doesn't really care. Like, as long as it's better than a human. Right?
That is literally, actually, the way we do it is that we have a driving test. So when a person learns to drive, you don't sort of sit them down in a surgery and inspect the neurons in their head to see if they've actually understood how to drive. What you do is you take them out in a car and see if they can drive, which is exactly what we do as well. The idea is you can run that both in simulation at scale and in the real world. And then we have a complex, quite a nice system of evaluating the models on different competencies, which is very similar to an actual driving test. So that's kind of where our safety case comes from.
Cool, thanks. Okay, I'll do one more here and then we'll jump into the room. So can you reliably correct the predictions of an auto-labeling system, or do you just have a confidence threshold and trust the neural network to tune out the noise?
Good question. So we do take a small sample of these images and kind of check them or compare them against hand-labeled third-party labels. The problem is that actually the third parties also use basically auto-labeling. They're just, kind of cheating. So their labels themselves, when we go through their data sets and check those by hand, they don't have significantly better accuracy. Well, it's a bit better maybe, but it's hundreds or thousands of times smaller scale. So we have an idea of how accurate the teacher labels are. And inaccuracies, I guess would contribute negatively to the performance of the end control model.
Cool. All right, brilliant. Anyone, just raise your hand if you've got a question. We'll pass the mic around.
Hello, great presentation. My question is, did you consider an API like Scale AI or others before coming up with this approach? And also, what other self-driving producer, what other approaches they use? Is the same like yours or different?
Good question. So when I talk about third-party labeling tools, Scale is what I'm talking about. So we do use them, but the scale at which they operate is like more than millions smaller than we need. So that's why we can't use that for training our models with. And as for our competitors, I don't know what they're doing. Hopefully, maybe we can poach someone from them and ask. But they also we don't really have competitors doing end-to-end learning like this. So I don't know if they need to do teacher labeling in the same way that we do. Certainly I don't know what their approach would be.
Thanks for your talk, very interesting. So we use a very similar stack. We also use PySpark operators on AKS, but I was wondering, what are you using for task orchestration? Is there any kind of tool or method you're implementing?
What do you mean by task orchestration?
So you have multiple tasks running at the same time. So all of these operators running at the same time. Is there anything that is managing the workload, or is it just first come, first serve?
Oh, I see. Yeah, like a scheduler. At the moment, we're just using like Kubernetes native scheduler, and we don't run more than one of these at a time because just one of them will use the entire cluster. So there's no benefit to, basically we just ask the next researcher to wait. Although Julia's PR today is enabling like concurrent labeling jobs. But then still, like if you have two labeling at once, they'll just be able to get to use 450 nodes. But I was looking at the Volcano scheduler as
Yeah, the reason I'm asking is because we're using Airflow as a scheduler, as an orchestrator. And in this circle of Spark, Airflow, AKS, we found it to be a vicious circle of all kinds of bugs and problems that you can encounter. So that was our experience, at least.
Yeah, our data engineering team has spent the last 3 months getting rid of Airflow. So I don't think they're very pleased if we install it again.
Hi, thanks for coming tonight. How do you, in your end-to-end model, how do you encode the route? And could Wayve eventually drive me up a 1 kilometre gravel road that isn't marked on OpenStreetMap or something like that to a destination? Is there any way you could put that in as an outcome?
Good question. So we use like standard maps, like Google Maps, essentially, and we condition the behavior of the model on where it should turn at the junction. Is basically how it works. As for what would happen if it goes on an unmarked route or like something that's not part of the maps, I have no idea. So basically, the driving domain in which we want to operate in the foreseeable future will be in cities, where we hope that there's none of those. But yeah, I have no idea how we would deal with that.
Thanks. Anyone else? Okay, cool. Well, Alex will be around and you can ask questions in the break. Just wanted to say thank you again. Really interesting talk. Let's have a round of applause for Alex. So we'll have a short break, go and grab some more food, grab another drink. The loos, by the way, if you need them, are right at the back through that almost invisible grey door. And then when we rejoin in a few minutes' time, Byron's going to be talking about building cross-functional data science teams. So, see you in a sec.
Should I just close this tab now?
Yeah. Okay, you want to say something?
Hi, everyone. Oh, that's... Hello? Hello, 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 hello.
Want to say something?
Hello?
Okay.
Is that any better?
Yeah, that seems better.
Okay.
That sound all right? There was a bit of feedback, but maybe it's okay. All right, we'll try it. If not, we can pass the mic between each other. So hopefully you can hear this okay as well. Cool. All right. Yeah, thanks again. We're going to get started in just a second. 2 more announcements before we do. The first is that the next meetup is on the 6th of September. So we've got the date locked in already. I've got 1 talk locked in. Some of the engineers at Sky are going to talk about a new open source project that they've built on top of Kubernetes. So yeah, please come along and watch them and support. And mark your diaries, right? Because it's a couple of months from now, but hopefully you're all back from your summer holidays. The second one, and this kind of relates, right, is that I'm always looking for more people who want to speak. Alex's talk just now was because he came along to some of these sessions, was chatting to people, and I sort of slowly convinced him, do you know what, there's always a huddle of people around you asking interested questions about autonomous cars. Wouldn't it be great if you could stand up and talk to people? So, there we are, right? And that was really good. So, yeah, regardless of what you do, you always have something interesting to say. Please come see me, or there's a speaker request online form that you can fill in on the meetup page. But yeah, always interested to hear people's stories. And you don't have to be doing 1,000-node GPU inference, right, to be able to give a talk. It could be, hey, I'm first year into my data science career. Here's what I'm finding really hard, and here's what's amazing. That's still a really interesting story. People love to hear about other people's lives. So yeah, so come find me if you've got that. And then what I thought we'd do here was just different from our usual kind of just doing a couple of talks. Is we're going to do a bit more of like an interactive fireside chat. So I'm going to ask a bunch of questions to Byron, and then we'll just open it up and do a bit of an AMA type thing. If you haven't met Byron at some of these meetups or seen him online, does a lot of talking and podcasts and things around MLOps and data engineering and AI. He works as an AI and ML lead, is that right?
Yeah, I'm the practice lead for Contino.
Okay, yeah, at Contino, so a consultancy who specialize in like cloud native and AI technologies. And he's also just released a blog on building effective data science teams. So that's kind of why I thought like it'd be good to have a chat about that. And then it can get broader from there. So hopefully the mic won't echo too much. If it's really bad, actually, if someone on the stream wants to say if it's really bad, and then we'll fix it, I will get started. Okay, so Byron, do you want to just introduce yourself and give us a bit about your background? That'd be
Sure. So my name is Byron Allen. I'm the AI and ML practice lead for Contino. Hopefully this is okay. Based on your face, it's bad.
Okay,
all right.
Okay. Hang on, we're going to swap the mic. It will be 30 seconds. We'll do it live though. So
I'm glad somebody did it though.
If this one doesn't work, then it's you.
Hopefully my voice isn't that good. Cool, thanks.
All right, let's try. Okay, do you want to say something?
Hello.
Okay, say something again.
Hello.
Oh, shit. Do that one. Might better than I Maybe it's better with the echo. Oh, it seems all right.
Do we need to turn this one off?
No. Okay. Uh-oh. Okay. I'll turn it right up. Say something again.
Hello.
Oh, yeah. That's good, right?
Is that better? Yeah? Okay. All right, perfect. Thank you.
Okay.
So, yeah, I'll start over. My name's Byron Allen. I'm the AI and ML practice lead for a company called Contino. Contino is a consultancy. We're a global consultancy, but relatively boutique. We have kind of a storied background in DevOps, but in the last 3-4 years, we've branched out into other domains. So we focus on DevSecOps as well, and we have a software engineering practice, and then we have my practice as well, which is the AI and ML practice, along with our data practice, which is a little bit larger. So, yeah.
Cool, yeah. As I was saying, right, Byron just released, actually on Friday, I think, your newest blog.
Yeah, last week, yeah.
Which was interesting because it kind of covers, as I said, like building a cross-functional data science team, but also like you picked up on some kind of things that you've seen in the industry as a practitioner, right? I guess the nice thing about being a consultant is you see lots of different companies. You get to see people have the same problem over and over. And yeah, one of the things you did at the beginning of the blog was you talked about 3 different pitfalls of data science. So do you want to go into those and explain kind of what those are and why you see them?
Yeah, so there's 3 pitfalls that I've kind of seen repeatedly over the course of the last several years. One is kind of this idea that the more people you add to a team, the better it will be. Sort of like throw as many engineers as you can at a problem. Seems to be a repeated pitfall. The other one is probably the one that most of us are very familiar with because it gets talked about a lot, which is this transition from experimentation into production. Not that many models necessarily reach it to production. We've done surveys and research that indicates that most of the companies out there only have a handful of models that are in production. In particular, any company that's not in banking or just a technology company themselves, they maybe have less than 5 models. So getting into production is challenging. And then kind of the final one is this idea of chucking things over the fence, or you could call it, domain silos, so to speak. The idea being, well, I'm a data engineer, so data science isn't my job, or I'm a data scientist, so data engineering isn't my job. And yeah, okay, this is pretty a common experience I think a lot of people have had. Yeah, so they're very common, and they're challenges that crop up again and again. Yeah.
Okay, so I'm actually going to ask you probably the most difficult question now, which is, and this actually came up earlier when I was chatting to, sorry, I've forgotten your names. But, yeah, Alex and Gemma, right? And we were saying the kind of mess of like the MLOps buzzword, like what does it even mean? Where for you, where does MLOps start and where does it end? Right? How much of the stack does it cover? Like, is it data labeling? Is that part of MLOps? Is actually manually going out and collecting data still part of it? I don't know, right? Yeah. What does it mean to you?
So MLOps to me is, oops, it's back again. MLOps to me is, it could definitely encompass those things that you mentioned. And the way I like to describe it is, whilst we often talk about MLOps and like tools and technologies, but it's also the people, the practice of setting this up, the best practices, the way you run a team. And that's what we've, at least at Contino, we've had this experience where we've come into countless clients, and it's not often the technology that's the blocker and the key enabler. It's usually how you do things. It's the people in the process that seem to matter the most. And I think that's true for MLOps as well. So establishing those processes and those people and putting them in the right place really helps facilitate ML in production. So that's the way I look at it.
Okay, cool. And then I'm going to ask you the same thing, but for data science. Again, like where does that stop, and where does it overlap with MLOps? Yeah,
I think I look at data science as a part of the MLOps lifecycle, as a part of this greater whole. So to me, data science is really about experimentation and figuring out what works. So, and I think this is kind of also where the trade-off between science and engineering takes place. In science, you try to figure out what works. Engineering, you're trying to build something that lasts. So it's two sides of the same coin when you're considering MLOps, because you're trying to build something that lasts, that's repeatable. But in data science, you're trying to drive that initial value, that initial proof point, so that the idea can be invested in and then brought into production. So I guess maybe that's not as detailed.
Yeah, I guess what I'm thinking there is like, is it possible nowadays to still be a data scientist and not know anything about MLOps or even have to care, right? Because it comes up all the time, and people are like, oh, I keep seeing MLOps, I feel like I should learn it. I don't know if I want to learn Kubernetes though. And there maybe there are still data scientists who just do like data exploration and analysis and don't ever write machine learning models. And so maybe MLOps isn't for them.
I think there is still a place for that purely analytical version of a data science, but I do think you can't not care about the next steps. So anecdotally, we worked with a client that they'd never used Python, they'd only used Excel, and they came from a pure maths background, and they had a model that was driving value, but it was all built and run in Excel. And to bring it to its next fruition in its life cycle, we helped to skill up that team into best practices around Python and how you can actually do this better with more modern tools. And so I think you have to care in order, if you desire doing something more with what you have right now, I think they have to care. If you want to integrate with other teammates, yeah, you have to care.
Okay, yeah, that's a pretty good answer. Okay, something you mentioned in the blog, and you talked about a bank as an example. I think you told me you're not allowed to name the banks.
Yeah, I can't name them.
But we can make inferences, right? We all work in machine learning. You had a quite good example of like how working in silos can mean things go disastrously wrong. Do you want to run us through that? I thought it was quite interesting.
Yeah. So what I focus on in the early stages of engagements is design and working with clients on discovery. And one of the key things that we do is we bring the right people to the conversations early on to avoid pitfalls like this one client had experienced in another setting. Essentially, they had worked with their data scientists, their data engineers. They brought those people to the party, which was great. And they identified a KYC model that they wanted to pursue. And they built out this model that was helping them to automate that KYC process, but they didn't include the KYC team itself, so the domain stakeholders. As you can imagine,
Can we just clarify KYC for people who aren't up with their TLAs?
Know your customer.
Okay, cool.
So KYC is a fundamental part to banking. Every bank has this process. You probably have filled out a KYC form at some stage in your life, or you certainly will at some point.
Cool. Yeah, sorry. Yeah, do continue.
So if you not involving the domain stakeholders, obviously threw up red flags for the domain stakeholders, and they became a blocker rather than an advocate. But involving people at key earlier junctures is something that can be impactful in the sense that it removes them as a blocker and makes them an advocate, so you can actually get things done faster.
Okay, cool. And then, in your opinion, apparently there are 7 key roles to building a cross-functional data science team. So, can you tell us? I guess just tell us what they are first, and then we'll dive into some of the roles.
Yeah, so I look at them as archetypal roles, so in the sense that it's an archetype. It's not meant to be. There's always supposed to be 7 roles on every data science team, but these are kind of the archetypes you might want to aim for. So you would have your data engineer, your data scientist, stroke data analyst, an ML engineer, what I call a data science leader. And I use that term specifically because instead of like a senior data scientist for a reason, and I'll get into that. You have a domain expert, software engineer, which kind of covers a few different areas, and then a statistician. So those are the 7 kind of archetypes to form a team, but it doesn't necessarily mean always 7 people.
Okay, yeah. So thinking of that list, right? The one that jumps out, as you already touched on a bit, was like senior data scientist and data science leader. What's the difference there, and why do you need both?
Yeah. So senior data scientist to me often means kind of a data scientist who's very skilled, who's very technically knowledgeable. Whereas when I say data scientist leader, the idea is that this is somebody who's playing a uniting role, maybe not politician, but they're good at bringing people together, and they're good at bridging, particularly you might have your data engineer, your data scientist, but what about your domain expert, your software engineer? Bringing all these people to the same table and getting them to speak the same language can be very challenging. And they also sometimes have different agendas depending on how an existing organization is structured. You sometimes have siloed teams, and the agenda of the data engineering team is not always the agenda of the data science team. And then the domain stakeholder might have a completely different take on it as well. So you need somebody to really unify. And that's why I say it needs to be a data scientist leader.
Okay, so it's kind of like a bit of herding people around and project management and stuff as well as the data science work?
Yeah, I definitely think that's a part of it. Yeah, you have to kind of wear that hat as well.
Okay, and then the one that stands out as like, why is that there, is the statistician. Like what role do they provide and what is that?
Yeah, so I make that distinction between statistician and, let's say, data scientist. Some people might think of them as the same thing. But I think oftentimes data scientists, data analysts, we're creating a hypothesis, we're creating a question, we're trying to drive out value, but sometimes the question is biased in itself. You might want some sort of safety valve. And that's the idea of the archetype, is that statisticians is there to validate the question, there to validate the assumptions of the data scientists or data engineers that are on the team.
Okay, cool. And then something as well you talk about is like, and you mentioned there not necessarily have to be 7 roles, right? Because if you're a team of 1, then tough luck, right? You got to do 7 jobs. But there's an element of that. Like you still need a lot of these, if these are the capabilities, if we call them that you need to deliver a fully fledged AI project, how do you go about managing that if you're a team of 1, right? And you're trying to do too many things at once?
I think it's probably very much close to impossible to wear all 7 hats alone and be a solo operator. I think it's just too much work. So I think individuals, I use the term like wearing different hats, and I think you can't wear 1 hat or 2 hats at the same time. You kind of have to spread yourself out, and you can wear another hat and put it on for a second, but you can't. It's like you can't have your cake and eat it too. It's kind of the same principle. You can't wear all hats at the same time, but maybe you can juggle between 1 or 2, or at least wear another one that's different than your own hat long enough to empathize, to appreciate what the other person is going through, and learn how to speak their language, and just make everything a bit more smooth in terms of dealing with them.
Okay, cool. I guess there's been a lot of me asking questions here, right? This is probably a bit more fun if people get to be engaged. Feel free, just raise your hand if you want to ask something. It could be you can be way less friendly than I was. You can just be like, "Hey, what's the shittest tool you've ever worked?"
Be brutal. It's fine.
Yeah, like who's your favorite team member, etc. Okay, we got one back there. Likewise for people online, if you want to throw them in the chat, I'll have a look in a second, and then we'll ask those.
Hi, thank you. Since you operate in a consultancy, I would be curious to know what's your model when you work in a project. So you go to this company X and they have terabyte of data aggregated, maybe aggregated, maybe not aggregated. So what would be your kind of preference for stack to build in order to first aggregate this data in something that can be consumed from data science? Because I guess that the problem for data science is first to actually have the data available. I wonder how you operate.
So it was a little hard to hear, but it sounded like, are you asking me what my favorite stack is?
Yeah, what's going to be your stack to build the stack, to empower the people to actually do data science?
Yeah, so my favorite tech stack would probably be, I don't necessarily have one favorite. Sorry, hopefully I'll try to keep it far away. My favorite tech stack, I've spent a lot of time in GCP, so I have a kind of I like BigQuery a lot. But increasingly, I have a bit of an interest at the moment in Snowflake, Feast, and dbt as a combo. It's something we're going to start working with a bit more. But I think something that's what I've seen in some recent work that I think will be kind of a future trend is leveraging modern data warehouses like Snowflake, like BigQuery, and having some form of a semantic layer in between it. We did some work recently with Looker, and that's actually become one of my favorite tools. So in terms of favorite stacks, maybe like Looker, BigQuery, but it's not a silver bullet at all. Does that answer your question? Sorry. Yeah. Okay.
Cool. Yeah, we'll go over here.
I have two questions. The first one is, if you see any company today, especially if a product company, it's impossible to survive without adopting DevOps. Now, similarly, do you think that, with machine learning being adopted more, there will be a time where without MLOps, software development or product companies will almost struggle to survive? That's first question. I hope you've got the first question.
So you're saying that without or
MLOps,
without like MLOps will be dead? Like
yeah. Will it be not almost dead, but it'll not progress further because there is a close correlation between software and data now.
Okay. Yep.
That's the first question.
Yeah.
The second, I think Alan also mentioned that a lot of the models which they're building in, testing those models is always challenging. How do you find it? Since you do a lot of consulting with different customers, do they always find it tough to test all these machine learning models, and what kind of what kind of things are they doing to overcome these challenges?
Yeah. Okay. So to your first question, I don't think MLOps will necessarily disappear, kind of like blend in with DevOps. At least, maybe that's also a semantics question, right? Fundamentally, I think there's kind of three kind of ops. I would say there's DevOps, there's data ops, and there's MLOps, because you have three different layers of artifacts. You have your code, you have your data, and you have your ML artifacts. And they all kind of require slightly different tools, and I think there's different skills and processes that kind of are attached to those. So I don't think MLOps will necessarily disappear, at least not anytime soon. Like maybe eventually it'll all kind of come into one thing. And I guess, sorry, what was your second question again?
So the second question was that how is testing being done?
Testing. So, I mean, I think you have a lot of different tools out there that are useful for testing. Right? It depends on what you mean by testing. And I think it depends on what mode, like what use case you're talking about. And I break it up primarily into two, because these are the two scenarios I see the most. One is, you're looking at batch processing, and the other is online processing. I think if you're looking at batch, to me, I always kind of end up drifting towards using modern data warehouses as kind of a backbone for that. And a lot of testing can be driven off of them now, and in kind of some unique and different ways in the last couple of years as well. I think when it comes to online processing, it becomes a little bit more challenging and more difficult to do, especially at the point of inference. And if you have something that's really time sensitive and you need to really update it quickly, it becomes a bit more challenging, because you have to think about a streaming process and how you aggregate your data and all the complications that come with that.
Okay. So you've mentioned 7 types of roles in a cross-functional team.
Yeah.
But for example, if we take the machine learning engineering role, up until maybe 5 years ago, it was almost non-existent.
Yeah.
So how much more fractionalization do you think we'll see? And whether like any of these roles will be split up into even more roles?
I think you could probably see a lot of fractionalization. I mean, like the idea of like an analytics engineer is something that's relatively new. I mean, maybe next we're going to have a data mesh engineer as well. I think the industry likes to fractionalize and come up with new roles. It promotes new ideas. And some roles will stick around, some won't. I think fundamentally the ML engineer role is important, and I left it in the list instead of kind of discarding it, because I think it is, they're just, that difference between data science and data engineering, it always kind of creeps up. And I do think you kind of need someone to play peacemaker a bit in a way. And that's kind of what an ML engineer is in a lot of senses. It's the person that appreciates both sides and kind of can play a uniting force. And they also are supposed to be the individual that really understands how to orchestrate this job, which data engineers may or may not, depending on what the definition of a data engineer is in a team.
Yeah, that makes sense. Thank you.
correct me if I'm wrong, but I don't think you had a product owner in that list of 7, amazing people in a cross-functional team. Maybe I'm thinking of this too much in an agile sense.
No.
But I guess is a product owner not needed?
So I would say there is a product owner in the sense that I see them as kind of sitting outside. Like in Scrum, you would have your like Scrum Master, and then you'd have all your people attached with the team. I would say that that product owner kind of sits out to the side of it. They're obviously incredibly important, right? The one thing though that might become the blog post number 2 for this is taking that cross-functional team and moving it into a product team, which I think when there are data science teams that are more focused on exploration and getting to business value, but then what does that mean when you want to take that and turn it into a product? I think things kind of change and certain roles have to evolve a little bit.
Hi, you mentioned 3 classic problems. Second one was getting models into production, and third one was the silos or throwing models over the wall problem. So is the second and third problem the same thing or related? Or if not, can you expand a bit more on the second problem and the causes of that, getting models into production?
Yeah, I think they are related. I think kind of that disunity between data science and data engineering can definitely hinder the ability to get things into production. It can slow it down. So I think that's one aspect of it. There is another aspect of getting things into production, which is just skills as well. And I think a lot of people are still in their kind of early stages of getting skilled up in terms of machine learning and also data. Like data hygiene is still something that a lot of organizations struggle with. So I think there's that aspect of getting people skilled up to actually address the problem. And it's maybe not necessarily just data science versus data engineering. It could be more broader within an organization, or more specific, which is, there's a lot of tech debt that comes with machine learning, and that can be a challenge to deal with.
Hello. In the last couple of years, like 2 or 3 years, we've seen a plethora of tools like Hex, which is a GitHub for data science. You have observability tools, data pipelines. My question is, do you see all of them or most of them useful, or do you see also the number growing because the use cases are growing also?
So like with the growth of these different kinds of products that are out there, like we're kind of saturated with products, and there's going to be more that kind of come out. And I think it can be a challenge kind of getting a handle of what does what and what, like where do I place this new product? Where is it useful? That can be a challenge. But some of these products are really useful. They have maybe something that services a few key clients, and they're able to be successful, and they find a place where they can provide value. So, I mean, I think, is it useful? Is that the question? Like for all these products, I think if they survive, then they've proven that they can be useful. But I do think one of the interesting things about this proliferation of products is it kind of, if you start like trying to create a pipeline with all of these, you kind of have broken up your pipeline into a bunch of different products, which can also add complexity to observability. So, I don't think making your entire ML pipeline product centric is great. You'll have to build things in there to make sure that you have the level of observability that you want. So I think it adds more questions as much as it solves questions as well.
Yeah. Your comment about like the thousands and thousands of MLOps tools, right? And let's see which ones of them will survive. Couldn't be more poignant given the current like tech investment market and general economy at the moment. So we'll see. I guess we could like. Who doesn't have enough runway for the next year? Let's see what happens.
Yeah.
Cool. Any other questions from the room? Okay. A quick one from me then, and then we'll wrap up. Do you work across industries?
Yeah.
Okay. And then, so which is the most backwards one that you've worked with in terms of
most backwards one?
Yeah. Like there's always that one you walk into and you're like, oh my God, you guys are in like 2012.
Maybe utilities.
Okay. Yeah.
Not always, but like there are a lot of utilities companies that are old school. And, given the operating model of utilities, it can sometimes be hard for them to come into the modern era.
Yeah, that's probably fair. I think they're fairly backwards in everything. From when I used to do like cloud architecture roles, it was like despite having like the most like brilliant engineers and the smartest technology on the planet, it's like aerospace and defense companies were just like, how can you build a fighter jet, but you are literally using software that's been out of date for 10 years? It was just like unreal that they could manage to do that, but somehow it works for them, right? And so,
yeah. I mean, captive market. I don't know.
Cool.
On the flip side, what would you suggest is the sector versus used to?
Oh yeah, good question. I'm going to repeat that just for people online. So the question from the audience there was, which sector is most advanced, right?
So the most advanced sector, okay, aside from technology companies, from what I've seen, I would say finance, and more so within like the startup scene. Like if you look at the neobanks in particular, I would say like a lot of what they do is really quite impressive. And that's probably the most advanced and just a knee-jerk reaction.
They have a pretty hard ROI on like fraud detection, don't they? So they need to be pretty good at that.
Yeah, definitely. And also, I mean, just the fundamental thing that they drive in terms of its value and disrupting traditional banking. Like you can't have that without being quite savvy with your tech.
Cool. All right. Well, what we'll do is we'll wrap up there, and then if you have other questions for Byron or Alex, you can go and grab them. Don't keep them too late. I'm sure they want to get home at some point, but I think there are still some drinks kicking around and a little bit of food in there. So yeah, please feel free to stay for a bit. Network. Kind of one of the best things about this is getting to meet other people who do similar jobs and chat about what you do, what you struggle with. Maybe other people can help out. Go and don't just ask Alex questions as well, right? He was at the end asking for recommendations, so go and give him some tips if you think you can improve his process. So yeah, big thanks to Byron. So let's do a round of applause.
Thanks everyone.
And then just a final reminder that it's 6th of September is the next one. If you're all on the meetup page anyway, so it'll go out on there, but put it in your diaries now. And thank you all for coming.
Thank you.